This video will serve as a review for your third exam as well as for your final. I will provide more final exam material, but I just figured that I would do this for you guys as well. So if you subtract it, and remember this is also posted and I will post a worked out answer key. If you subtract negative 3 from 7, what do you get? So remember, no calculators are allowed. This would be 7 plus 3, which is 10. Subtracted from means the second minus the first. Find the first 3 decimal places in the expansion of 6 over 7. Actually, let me do this over here. So 7 goes on the outside and 6 goes on the inside. And the first 3 places means that we are going to go out 3 places. So 60 divided by 7 would be 8. 8 times 60 is 56. This is all long division. 40 divided by 7 would be 5. 5 times 7 is 35. And 50 divided by 7 would be 7. 7 times 7 is 49. 0.857 is your answer. Number 3, now because the negative is not inside of the parentheses, we are only squaring this, raising 2 to the 6th power. If it was negative 2 to the 6th, then everything would be raised. So I'll show you the difference. 2 multiplied by itself 6 times is 64, and then we negate. This would be the same as multiplying negative 2 by itself 6 times. Remember that a negative raised to an even exponent becomes positive, and this would be positive 64. So the correct answer here is D, but just be on the lookout. They like to ask this kind of question. Which is not rational. So every fraction is rational. I'll put Y, fraction. This is rational because it's an integer. This is irrational because it is a non-perfect square. If you are left with a radical in your answer, then it is not rational. A lot of people think that 3.14 is pi. It is not. It is just 3.14, which we round the digits of pi to. This is not pi. Don't think they're the same. So this is rational. It is a terminating decimal. I want to write terminating decimal, but this isn't letting me put. It is terminating decimal. Okay, it would have to say pi for it to be pi. Number 5, the multiplicative inverse. So the first thing you need to do is change this into an improper fraction. 3 times 5 is 15. 15 plus 2 is 17 over 5. This is not the answer. This is the improper fraction. The multiplicative inverse is the reciprocal of this, which would be 5 over 17. Okay, notice how they put A in there to trick you. Just to add on to this question, the additive inverse would just be to negate it. So that would be negative 3 and 2/5. Number 6, you are substituting. So 2 times 3 minus negative 4. 2 times 3 is 6, plus 4 would be 10. And the absolute value of whatever is in here always comes out to be positive. Choice A. Number 7 is another substitution. Whenever you are substituting, it's always a good idea to use parentheses. So negative 3 squared times negative 2 minus 2 times negative 3 times negative 2. So I would do this piece and this piece separately and then make your combination. Negative 3 squared is going to be 9 times negative 2, which is negative 18. And then you have minus 2 times negative 3 times negative 2. So you can realize that a negative times a negative is a positive, and a positive times a negative is a negative. So this will be negative 18 minus 2 times 3 is 6, 6 times 3 is 12, negative 30. Choice D. Okay, so all of your sign number rules are old rules from way back when. Number 8 is just order of operations. So 7 plus negative 3 minus 4 minus 3 squared in the absolute value. So we would treat the absolute value like parentheses, meaning we would simplify it first. This will be 7 plus negative 3 minus the absolute value of negative 5. The absolute value of negative 5 is 5. 7 plus negative 4 is the same as 7 minus 4, which is 3. Let me just check on that. So 7 plus, I'm sorry, that was a 3. 7 plus negative 3 is 4. 4 minus 3 is, 4 minus 5 is negative 1. That typo. Okay, whenever you square something, you have to multiply it by itself. A lot of you did not do this in your radicals, so be careful. 2x squared times 2x, 2x times 2x is 4x squared. 2x times 3y is 6xy. 3y times 2x is another 6xy. And 3y times 3y is 9y squared. The only terms that will combine are your middle terms. So the answer is 4x squared plus 12xy plus y squared, which is choice A. Number 10, you're going to simply distribute each term of the binomial into the trinomial. So x times x would be 2x cubed, x times 2x squared, minus 5x squared, plus 2x. So now you can line up your terms underneath. This is a negative 6x squared plus 15x. Makes it a little easier to combine, minus 6. 2x cubed minus 11x squared. These are all like terms. This would be choice, this is 17. This would be choice A. Another order of operations question. So brackets would be the same like parentheses. We want to do what's inside of the brackets first. Okay, so 3, remember there's a times here. 4 minus negative 5. 4 minus negative 5 would be 9. Okay, so you'd really want to do the exponent. You can also knock this multiplication out because they are separated. So this is 27 plus 3 times 16 minus 15. This would be 27 plus 48, which is going to be 75 minus 15, which is going to give us 60. Choice C. A lot of you need to practice this. So this is a difference of cubes. Of course, we want to make sure there's no GCF, which there isn't. The cube root of each of these is x and 10. By the way, multiple choice does help you. Every answer choice has that, so that can really help you in an exam. X minus 10, because we start with minus, the binomial goes minus. We go opposite the sign, and we always end with plus. So whatever we start with is what goes in the binomial. We take x and we square it. We take 10 and we square it. The middle term is their product. The correct answer here would be choice C. This is just distribution and combining like terms. So negative 5x times x is negative 5x squared. Negative 5x times negative 2 is positive 10x. And the 3x is out in front. Negative 5x squared plus 13x gives me choice B. Factoring a trinomial when a is more than 1, we use the a times c method. So 2 times negative 5 is negative 10. Factors of negative 10 that add to our middle term of negative 9. Well, 1 and 10 definitely get us to negative 9. 10 has to be negative, 1 has to be positive. We use this to expand our middle term. Again, where you place your terms is up to you, but I'm going to put the negative 10x with the 2x squared. Whenever you're grouping, you should always have a plus. I'm going to put the 1x with the minus 5. We factor out the GCF of each of the binomials. So the GCF here is 2x. And the GCF here is 1. If you notice, this is already an x minus 5 and an x minus 5, but you have to factor out something. 2x plus 1 and x minus 5. By the way, if you get stuck on a final, just multiply each choice through until you match what you started with. Again, it's not my favorite option, but it's better than not doing anything. The next one, we're going to cube the top first because we have to apply the exponents. 2 to the third is 8. X to the 3 raised to the 3 is x to the 9. Remember, you multiply when you raise a power to a power. Y to the 4 raised to the 3 is y to the 12. 8 and 24 reduced to 1/3. You know that if you look at all your choices, you can see that there is a 3 involved. X to the 9th over x to the 3 is x to the 6th. Y to the 12 and y to the 14. So remember, when you get a negative exponent, you place it in the opposite part of the fraction to make it positive. The correct answer here is x to the 6th over 3y to the 2nd. Choice A. Factor completely. So remember, we always check for GCF first. There is a GCF of 2, revealing x cubed plus 64. This is now a sum of cubes. You have to be able to recognize that. But if you look at your answer choices, 3 of the answer choices reveal that. And as a matter of fact, this x plus 4 also reveals the cubes of each of these. The cube root of x to the 3 is x. The cube root of 64 is 4. Don't forget about that original GCF. A lot of people do that, and then you pick the wrong choice. So we know choice B is out, as well as choice A. X, so I started with plus, so my binomial goes plus. This would go minus. This always ends with plus. This squared and this squared on the outside, their product, 4 times x in the inside. So the correct choice here would be choice D. So whenever they say to divide and you see remainders, this is going to be a long division problem. X minus 2 being our divisor, and 5x squared minus 3x plus 4 is our dividend. We take the first term of each and we divide. 5x squared over x is 5x. 5x goes on top. Then we multiply. 5x times x is 5x squared. 5x times 2 is minus 10x. We negate, so this becomes negative, this becomes positive. These should cancel. Negative 3x plus 10x is 7x, and we bring down the 4. Now, because this is the only bring down, this will be our last round. 7x minus the x, divided by the x, is 7. 7 times x is 7x. 7x times negative 2 is negative 14. 4 plus 14 gives us 18, so the remainder is 5x plus 7 with a remainder of 18. Factor completely, so we first check for GCF. There is none. This is a situation of a difference of 2 squares. So remember, that will factor into the same binomial with plus and minus as the only difference. The square root of 81x squared is 9x. The square root of 64 is 8. So 9x plus 8, 9x minus 8, choice B. 19, you have to remember to negate by distributing, so this becomes negative and this becomes positive. If you want to take the extra time to really write things out, you can. So the a squared b cubed and the a squared b cubed terms combine. You can cross them out once you use them. The a cubed b squared terms combine. And then we just find our match. 5a squared b cubed minus 7a cubed b squared. Choice A. Factor completely. So again, we're going to check for GCF. Guys, in multiple choice, look at this. This is definitely going to be our GCF. So this is extremely helpful. So noting that this is our GCF, when we divide 18x to the 3y by 2xy, we're left with 9x squared. When we divide 2xy, or factor it out from the second term, we are left with 4y squared z squared. This is a difference of squares, which can continue to factor for us. So this is the work you would want to show on your final exam. The square root of 9x squared is 3x. The square root of 4y squared z squared is 2yz. So the correct choice here is choice D. Okay, so use the multiple choice to your advantage. In this multiple choice question, you have the GCF right in front of you. Number 21, so 12 x to the 8th minus 20x to the 6th. When you have a binomial over a monomial, remember that you are going to separate and then divide. 12 divided by 4 is 3. X to the 8th over x squared is x to the 6th. Minus 20 divided by 4 is 5. X to the 4th. Your answer here is choice B. In our multiplication of rationals, you're going to factor everything completely. X squared minus 7x plus 12 factors into x minus 4 and x minus 3. Factors of positive 12 that add to negative 7. 4 minus x and x minus 4 is that a minus b over b minus a. That becomes a negative 1. 12 and 6 reduced to 2 on top. X to the 2 and x to the 3 leaves me with 1x on the bottom. I'm left with a negative 2 over x times x minus 3. If you notice in the answer choices, they do put the negative next to the fraction bar. It's the exact same thing, choice A. Number 23, we are going to use just quick distribution. 2x times 5x is 10x squared. 2x times 3 is 6x. Sorry. Then we distribute the negative 7, so negative 7 times 5x is negative 35x. Negative 7 times negative 3 is negative 21. Negative 10x squared minus 29x minus 21 when we combine our like terms. We need a common denominator, so a common denominator would be the least common for both of these. 20, 40, 60 would be our least common denominator. 15 goes into 60 4 times, so we have to multiply the top and bottom by 4. 20 goes into 60 3 times, so the top and bottom by 3. We get 3 over 60, which we clearly see is not an answer, but if we reduce that by dividing the top and bottom by 3, we get 1 over 20, which is the correct answer. 25, so we're going to factor first and then cancel any like factors. Our numerator is a difference of squares, x minus 5 and x plus 5. Our denominator is 5 minus x. A minus b, b minus a. We are left with negative 1 times x plus 5. They may distribute in the answer choice, but here we can see choice C matches. Negative in front simply means a negative 1, so they may write it that way. Our next problem, we are going to factor the numerator is a difference of squares. So we're going to have x minus 4 and x plus 4. And in the denominators, x minus 6 and x plus 4. The x plus 4s are the only thing that cancel. So we're left with x minus 4 over x minus 6, choice D. Complex fractions, we multiply by the LCD of all our little denominators, so x, y, x, and y. And then we cancel top to bottom. Everything cancels here, we're left with 2 on top. The x's cancel here, we're left with 3y. The y's cancel here, we're left with plus x. We can't simplify that anymore, so the correct answer is B. For number 28, you're going to determine an LCD, which would be a combination of both denominators. This denominator needs an x plus 2, while this denominator needs a 5. Now remember, you simplify your numerators first. So when I distribute here, I get x squared plus minus 3x plus 2x, which is negative x minus 6. Here I get minus 10. We are left with x squared minus x minus 16. And nothing else can combine, so the answer is choice D, nothing factors. We're going to factor to see if we can find a common denominator. So this denominator factors into this. We can see that both denominators have the x plus 4, but the least common denominator has to match, so be a combination of both. So we need to multiply this fraction by an x minus 4. Again, combining the numerator separately, when I distribute right here, I get 2x minus 8. I'm going to add in the second numerator because I'm not multiplying it by anything, and then over that common denominator. Combining like terms, I get 2x minus 5. And so just remember to combine those numerators separately first. Number 30 is going to be an LCD, so let's start with the numbers. 5, 15, and 3. 15 is the smallest that they all go into. X squared, and x, when we are identifying an LCD, we always go with the larger exponent. I'm going to rewrite the problem so we can see the change. So in order to make this a 15x squared, we have to multiply top and bottom by 3x. This is already a 15x squared, so no manipulation. To make this one a 15x squared, we will multiply top and bottom by 5x. Combining straight across, we would get 26x plus 7 over 15x squared, and we cannot simplify any further, so choice B. In this problem, the denominators are already factored for us, so we want to identify which of our terms or factors are the same. In this case, x minus 3 is the same, so let's see what this has that this needs. This has an x plus 3, so this needs an x plus 3. This has an x plus 1, so this needs an x plus 1. Again, you're going to combine, sorry I missed the x, but you're going to combine these first. So x distributed in is going to give me x squared plus x. Here I'm going to distribute the 2x. If you're good enough, you don't really have to go and write out the denominators in the middle steps. By the way, notice that the answer choices all are indicators of what the denominator should be. You may not forget to distribute that negative, so it's x squared plus x minus 2x squared minus 6x. I'm not going to write, let me write it. I wasn't going to write the denominator, but I don't want to confuse you. X squared minus 2x squared is negative x squared. X minus 6x is negative 5x. Now, you could factor out an x or even a negative x in the numerator, but nothing will combine, and as you can see, the answer choice would be A. 32. So in number 32, remember that you have to do keep, change, flip. Keep, change, flip. This is when you are dividing two rationals. The first numerator factors into a difference of squares. The second denominator, so if you want to step to the side, you can use that AC method. Okay, A times C is negative 30. Factors of negative 30 that give me x. 1 and 30 don't. 2 and 15 don't. 3 and 10 don't. 4 isn't divisible. 5 and 6 do. Positive 6 and negative 5. when we expand that middle term, we will have 2x squared. I'm going to put the 6x with the 2 and the minus 5x with the 15. Sorry, I'm smashing this in. 2x, I'm left with x plus 3. Minus 5, I'm left with x plus 3. So my factors are 2x minus 5 and x plus 3. Okay, here we're going to have x minus 8 and x plus 3, factors of negative 24 that add to negative 5. That's because a is positive, and then 2x plus 5. These cancel, these cancel, these cancel, x minus 8. The largest perfect square that is divisible into 32 would be 16. The largest square divisible into the square root of 8 is 4. This is 3 times 4 radical 2, which is 12 radical 2. This is 2 times 2 radical 2, which is minus 4 radical 2. Since they both have the same radical portion, let me just make sure. I wrote 3. This is 5. 5. So this is 20. So the answer will be 16 radical 2. When it says to rationalize the denominator, in the case of a binomial denominator, you use what we call the conjugate. It's the same exact denominator, but we just go opposite in the middle. 6 times 6 is 36. 6 times radical 3 is 6 radical 3. Conjugate pair, the middle terms cancel, so this is 36 minus 3. 36 plus 6 radical 3 over 33. If these three numbers have something in common, which in this case they do have 3 in common, you can reduce by that. 36 divided by 3 is 12, 6 divided by 3 is 2, and 33 divided by 3 is 11. Now, I just want you to notice that D is the answer, but what they did in D is they actually factored the numerator. They just did that more to trick you, so be on the lookout. If you notice, you could have distributed and matched your answer. 35 is a distributive problem. This is 14 radical 3, so we can start to see which answers it probably is going to be. Minus 10 radical 9, which is the same as 10 times 3. So that's choice A, 14 radical 3 minus 30. Remember that an exponent that is written as a fraction is power over root. In this case, every single thing will be raised to the 2/3 power. The root is 3, so the cube root of 64, which is 4 raised to the power of 2, is going to be 16. Right away I can see A and B are out. This is going to be x to the 6 over 3, which is x squared. This is going to be y to the 24 over 3, which is 8. Choice C. We want to eliminate any negative exponents always by putting that portion where the exponent is attached to in the denominator. The 2 is not attached to the exponent, so it can stay where it is, but the x squared is, so I'm going to put it in the denominator. This whole thing is attached to the negative 3, so that will also go in the denominator to allow it to become positive. This is 2 over x cubed times, now each piece gets raised to the power. 2 to the 3 is 8, x to the 3 would be x cubed, and y to the 3 is y cubed. The 2 over 8 will reduce to a 4 on the bottom. Don't remove that 1 on top, because remember, this is really 1/4. X to the 3 times x to the 3 is x to the 6. Remember, the rule there is to add your exponents, and y cubed. I don't know what's wrong with me. I keep writing this the wrong number. Sorry, that's 5. Choice D. Remember that when bases are the same, regardless of if they're numbers or variables, we add our exponents together. So 4 to the 2/3 plus 4 to the 4/3 is the same when we add the exponents as 4 to the 6 over 3, which is 4 squared, which is 16. Because both of these are under the radical, we can divide. 32 divided by 2 is 16. X to the 5 over x is x to the 4. And y to the, so again, I did this in the lesson too. Let me start that over. So it was x to the 4th, and then y to the 4 over y to the 12 is y to the negative 8. So we put that in the bottom. Remember that any exponents that are even, we just divide the exponent by 2 and it's a square root, perfect square. 4x squared over y to the 4th, choice A. Finally, when anything is raised to a negative exponent, we simply take the reciprocal of that fraction, and that will make it a positive exponent. 5 squared is 25, 2 squared is 4, and k squared is 4k. 2k squared is 4k squared. Choice B. There may be a piece or two missing that I didn't cover in this review, so please make sure you review all your notes, and I really do hope this helps you guys.